Well, as somebody said at the time, once you've chosen your Supermen, that only leaves you about 10,000 other problems to solve. Let's take a look at some of the major ones. Not least, how do you get men to the moon? The trouble with that is what goes up tends to come down. Now, at the time, they were doing a bigger version of that with intercontinental ballistic missiles, which is why they thought they could go to the moon at all. All they had to do was to stop the rocket falling back to Earth. And that's where the idea of an orbit comes in. If you fire with sufficient power, the rocket will come down halfway across the world, but at an angle. Reach a speed of over 17,000 miles an hour, and the rocket will fall, but miss the Earth and go on missing it like this. Next, you boost your speed to over 25,000 miles an hour, and the rocket will follow a new orbit, still trying to fall to Earth, but going out over 250,000 miles into space before doing so, like this. If the rocket's intercepted at this point by the moon, then the moon's gravitational field will attract the rocket just enough to change its orbit, swing it round the back of the moon, and head to Earth. A touch on the brake pedal, as it were, at the right moment, and you stay in orbit round the moon. Another touch, and you land. All you have to be able to do that is one of these, a Saturn V. And that is your next major problem. How do you build one of these monsters safe enough and accurate enough to risk putting men on top and shooting them at the moon? Well, the answer to that question is that you give it to many different people to each build and test one part. The figures on the Saturn V were astronomical. This first stage, made by Boeing, carried 530,000 gallons of fuel and accelerated to 6,000 miles an hour in 2.5 minutes. Stage 2, built by North American Aviation, increased the speed to over 15,000 miles an hour and went up to 600,000 feet. The third stage, built by McDonnell Douglas, would eventually take the speed up to 25,000 miles an hour, escape velocity. With the housing for the lunar module, the mother spacecraft, and the launch escape tower, the whole stack reached a mind-boggling 363 feet end to end.